Open various trace file types. In this section, we'll begin by looking at the Wiretap library. That library allows Wireshark to open all different types of trace files in various formats. Then we'll take a look at the old pcap format and the new pcapng format. In the last section, we looked at how the packets are picked up when we're doing a live capture on a network. We go through the drivers. It's actually dump cap that's capturing the packets. This is the point at which capture filters may be applied in the Berkeley packet filtering format, or BPF format, and then the packets are piped up to the capture engine. When we're opening an existing trace file from a drive, it's a little bit different. This is when we go through the Wiretap library. The Wiretap library in Wireshark recognizes so many different trace file formats that if someone handed you a trace file and Wireshark didn't recognize the format, you'd really want to question what they used to capture the trace file. I have a note here in the Wiretap library box. pcapng is now the default trace file format for Wireshark. This format allows us to save not only the packets, but metadata about the packets. Let's go over to Wireshark and I'll show you the Wiretap library. You can bring up the Wiretap library by clicking on the Open a Capture File icon on the main toolbar. In the Files of Type section, when you expand that, you'll be looking at Wireshark's Wiretap library. These are all the different trace file formats that Wireshark understands. So if someone were to hand you a trace file in, let's say, the Tamosoft ComView format, you'd be able to open that up inside of Wireshark. You'll see some interesting entries in here, such as JPEG, MPEG. There's MPEG up here. And that's because Wireshark understands those file formats. You really can open up a JPEG file with Wireshark. You wouldn't see an Ethernet header or IP header or TCP or UDP header, but you would see the breakdown of the JPEG file format. At the top of this list, you will see Wireshark TCP dump format, the standard pcap format. Below that, you will see pcapng format, and then you will see nanosecond live pcap. This would be a pcap file that has nanosecond granularity in the timestamp information. You would have had to use a specialized adapter to capture and timestamp at the nanosecond level. Wireshark pcapng, as I mentioned before, is the default format at this time. Notice that if someone sends you a gzipped pcapng file, Wireshark can automatically unzip that and display the trace file. That's true of many of the formats. Now let's take a look inside of the old pcap format and the new pcapng format. Information about the pcap format can be found on Wireshark's wiki page under Development and Live PCAP File Format. Notice that the URL is case sensitive. PCAP stands for Packet Capture. All PCAP files begin with a global header that is 24 bytes long. After that, for each packet that is contained in that trace file, you will find a packet header that is 16 bytes long, and then packet data with a variable length. If this trace file only has one packet in it, we will simply have the global header, one packet header, and one bit of packet data. As each additional packet is added to the trace file, we see an additional packet header and packet data. And it continues this way for all the packets in the trace file. Looking inside the global header, we can see there's the length value for the field, and then the name of the field, and then a description here. The magic number at the beginning defines the order in which you should read the trace file. It's also a file identifier. The magic number that starts out at the beginning of all pcap files is A1B2C3D4. And upon reading that trace file, you would look at the order in which this information comes up, and the rest of the bytes should be read in the appropriate order. Some tools may read the bytes in a different order than Wireshark does. After that, you'll see the major version and the minor version, and this is the version of pcap. The next section has the GMT to local correction value, and because most time is done in GMT format, this should probably be at all zeros. The accuracy of timestamps value is set at all zeros, and we'll see accuracy information inside the packet header in just a moment. The maximum length of the captured packets is set by default to 65,535, which is FFFF. We'll see additional information regarding lengths inside of the packet header. And then at the bottom we have the data link type. This value can be found in a table at www.tcpdump.org/linktypes.html. Let's look inside the pcap packet header now. Notice that we right away have timestamp information. The timestamp information is an offset since epoch time or Unix time, which is January 1st, 1970. To add on to that, we have the timestamp in microseconds. So these two fields go together to give us the offset from epoch time. The next two fields that we have are both length fields. The first length field defines the number of octets of the packet that's saved in the file, and the next one defines the actual length of the packet. If these two numbers do not match, then we know that someone has snapped or shortened the packet. Now let's take a look at pcapng. pcapng stands for Packet Capture Next Generation. You can find information about it at the link shown on this slide. pcapng format allows us to save metadata about each of the packets in the trace file and the trace file itself. You can have extended timestamp precision all the way to nanoseconds. You can have information regarding the capture interface, what interface someone was using on their system. You can get capture statistics, such as was a capture filter applied during the capture process. It also supports mixed link layer types, so we can capture on more than one interface at a time using pcapng format. The trace file itself can have name resolution information embedded in the trace file. So if I were capturing at my location and capturing internal name resolution information, when I hand you the trace file, you can pull up that same name resolution information that I see. In addition, pcapng format supports comments or annotations. You can place an annotation on an entire trace file, or you can place annotations on individual packets in the trace file. The format for pcapng is done as blocks. We can see at the beginning a block type field, which defines which kind of a block will follow. We'll take a look at the block types in just a moment. And then we have two identical fields, the block total length field. We have one at the beginning, right after the block type, and then we have one at the end. And the reason why we have two of these is to deal with the read order that someone may use when reading each block. Then we have the block body in the center. and that will be variable length depending on what the purpose of the block is. So notice that we don't have a global header in pcapng format. Instead, all of the global information for the trace file format would be found in a standard block. All the packet information would also be found in a standard block. Let's take a look at the block types. The first block type is the section header block, and this is required on every single pcapng file. This section header is very similar to the magic number at the beginning. When we see a trace file begin with 0A, 0D, 0D, 0A, we know that that's a pcapng format trace file. This provides basic information about the file. We also always have to have the interface description block, and that's block type 1. And that provides the information about the interface used to capture the traffic. These next blocks are optional. It's very common to see the block type 4, the name resolution block. This provides us with the numerical addresses and names that are seen in the trace file. And then it's also very common to see the type 6, which is an enhanced packet block. This is basically information about a single packet. Let's first look at a list of experimental blocks, and then let's open up a pcapng trace file in a hex editor so I can show you what this looks like inside the trace file. There are several experimental blocks, and if you'd like more information on each of these experimental blocks, you can take a look at the pcapng documents. Now let's take a look at a pcapng trace file in a hex editor. I've opened up the trace file called tr-ftp-http.pcapng inside of my hex editor. And right away at the beginning, there we can see the start of the section block. After that is the length value. And remember, the length value is in hexadecimal. So we need to convert that over to decimal. Hex value 84 is equivalent to decimal value 132. So there are 132 bytes in this block. We can see on the right-hand side that this is providing information about the host on which the capture was taken. It says 64-bit Windows 7 Service Pack 1, then the build number. The capture was taken using dumpcap version 1.10.3, and there's the subversion number. And we can see that this was taken from a Wireshark 1.10 version. You saw before with the pcapng format we have two length fields, and this can be very handy because it's easier to find the end of the block by looking for the second length field. So we have 8.4 up here at the start, and we can see 8.4 down here. That's the end of that first block, the section block. After that, we have a block type number of 1. This is the interface block. This block lists the length at 88, which is the equivalent of 136 in decimal. We can see the interface information over here on the right-hand side. There's the device number. We see some repetition here regarding the operating system that we are using. And here is the repeated length field. So this is the end of the interface description block. This next block is a block type 4, which is the name resolution block. And we can tell on the right-hand side by looking down here that this definitely is the name resolution block. Here's the length field for the name resolution block. A0 equates to 160 in decimal. We can see all of the name resolution information showing on the right-hand side. I'll just scroll down till we get to the end of the name resolution information. And all of a sudden things will start looking a little bit different, and sure enough, here's the end of the name resolution section. The next item that we see is number 6. This is an enhanced packet block, and you can disregard the leading values in here. So this is an enhanced packet block There's the length field, and now we're actually looking at a packet in the trace file. Probably one of the greatest features of this format is that ability to have all of this metadata with our trace file. Not all tools in the industry are ready to use pcapng format. So you may find in Wireshark that you still have to save your trace files in the pcap format. If you do, you will lose all of the metadata that you had in the pcapng format file.